Hi everybody, it's Mrs. Pound, and this is our last section in our chapter on chemical interactions. Section 144 is about ionic bonds. We've already talked about covalent bonds where electrons are shared, so now we're going to talk about ionic bonds. Our objectives are to analyze oxidation numbers to predict if an atom will lose or gain electrons, and determine formulas and right names for ionic compounds and hydrates. So an ion is an atom or group of atoms that has a charge. In ionic bonds, ions are formed, particles with charges. Ions have a positive or negative charge, and ionic compounds are neutral because the negative and the positive charges will balance out, a lot like the protons and electrons for an atom. So here is an example of an ionic bond. We see here that we have sodium and we have chlorine, and we have the electron dot diagram. Sodium is in group 1, so it has one valence electron. Chlorine is in group 7A or 17, so it has 7 valence electrons. And these bonds tend to occur between a metal and a nonmetal. And here we see sodium, because it only has one electron, it wants to completely transfer it to the chlorine. So over here, if sodium loses an electron, loses a negative charge, there's more positive charge in the nucleus than there is negative charge from the electrons. It becomes positive, and it lost one electron, so it actually has a charge of positive 1. The chlorine is now happy because it has a full valence shell of 8. Now sodium also has a full valence shell, even though it's not shown. Chlorine has a full valence shell of 8. It's happy, but because it took on a negative charge, it becomes negative. So that is how you would draw the bond, and we put the symbol in brackets to show that it's an ion. Now, positive oxidation numbers indicate that an atom will lose electrons. So if we go back, this positive here, we call that actually an oxidation number. Sodium has a positive 1 oxidation number, so it will lose electrons. So over here, chlorine has a negative 1 oxidation number. So what do you think it does? It gains electrons. Negative oxidation numbers indicate that an electron will gain an electron. And here is a chart to show you what common oxidation numbers are for each group. So group 1A generally has an oxidation number of positive 1. They tend to lose 1 electron. Group 2A has 2 positive oxidation number. They tend to lose 2 electrons. 3A, a positive 3 oxidation number. They tend to lose 3 electrons. 4A, positive 4, loses 4 electrons. Then we get to group 5. It has a negative 3 oxidation number. That means it tends to gain 3 electrons. 6A, negative 2, gains 2 electrons. 7A, negative 1, gains 1 electron. And then group 8, our noble gases, 0, because they don't like to gain or lose. They're happy with just what they have. Now, some elements have multiple oxidation numbers, and these are the elements that are in the middle of our periodic table, okay? Some common: chromium, positive 2 and positive 3, so it likes to lose 2 or 3 electrons. Copper, positive 1, positive 2, loses 1 or 2 electrons. Iron, 2, positive 2 and positive 3, loses 2 or 3. Lead, positive 2, positive 4, loses 2 or 4 electrons. And tin, positive 2 and positive 4, it loses 2 or 4 electrons. Now notice, metals tend to have a positive, or do have a positive oxidation number because they like to lose electrons. Nonmetals will have a negative oxidation number because they like to gain them. Okay, we also have what are called polyatomic ions. This is a group of atoms that are covalently bound and have a charge. An example is OH negative. So the oxygen and hydrogen have a covalent bond between them, but this whole group will bond ionically with a metal ion, with a positive metal ion. And then there are compounds that are called anhydrous. It means that they lack water. There are some compounds that are called hydrates, and they have actually water as part of their crystal structure. Um, we'll take a look at more of that in class. Now, today in this video, we analyze oxidation numbers to predict if an atom will lose or gain electrons. In class, we are going to determine formulas and write names for ionic compounds and hydrates. I'm going to give you the rules for that, and we are going to work on that in class. So don't forget your 5 questions, and you can start studying for the test. You should already be studying. Every day you should take a look at your notes, and then it will make everything easier for you.